organize into a frequency distribution, you will be able to present a frequency distribution into graphic forms. Once you prepare the frequency distributions, then based on those frequency distributions in the appropriate graphic forms, you will be able to interpret the shape, center, and spread of a univariate data set, which are presented in a graph, right? So using the graph, you will be able to interpret shape of the distribution, center and spread of the distribution, right? You will be able to select an appropriate graphical descriptive statistics to describe a data set. You will be able to list out the rules for presenting the graphs, and also you will be able to identify the methods in which graphs may misrepresent a distribution. So these are the main learning outcomes. So first we look at the introduction. Usually when we are looking at the raw data, which were collected directly from the subjects or elements for a study, then only just looking at the raw data, you can only get a very little information. Even what is the maximum value, what is the minimum value, right? These are only these kind of information you can get it. Even sometimes it will be able to find out which observations occur most. But even when we are having the very massive data, then even the identifications of the minimum number or the maximum number or which have most occurrence value is very difficult. Right? So only it reveals a very little information. So, but actually when we are collecting the data for some purposes. So if we want to determine the significance of the collected raw data, first we have to organize and present data into an informative way. Right? When we are organizing or presenting the collected data in an informative way, then at a glance, we are able to get an idea what we can tell from the data. So to organize and present the data in the significance manner, the following, first we are looking at the frequency distribution and it's a graphic distributions, right? Graphic forms and the tabular forms we are going to use to organize and the present data in an informative way. So in an informative way means when we are organizing the raw data, we are able to convert those raw data into a information. That is the ultimate purpose of statistics is that one, converting the raw data into an information, and that information will be used, right, to make decisions, right? So first we are looking at the qualitative data, right? What do you mean by qualitative data? Students, unmute your mic and answer. What do you mean by qualitative data? Or you can put your answers in the chat box. What do you mean by qualitative data? Unmute your mic. Otherwise, you write the answer in the text box. In 2 words, you can tell that. What do you mean by qualitative data? Qualitative are the data. The first one is wrong. Management MS3, the data which are non-numeric, right? The data which are not numerical, both are correct. If the data are not numerical, that just they are giving as a labels or categories, then they call as a qualitative data. Right? You look at the spelling, qualitative data. So these are the non-numeric data. So to organize the qualitative data, the following things we can use: the frequency distribution, or relative frequency distribution, or percent frequency distribution. Then these distributions we can represent by the bar chart or pie chart. These are the main commonly used tables and graphical methods to summarize the qualitative data. Right. First, we look at what is a frequency distribution. A frequency distribution is a tabular summary of data. It summarizes the data which table shows the frequency. What do you mean by frequency? The number of items in each of several non-overlapping classes occurred, right? So it shows the frequency table or frequency distribution is a table, right, which summarizes the data which shows the frequency of the items in each of several non-overlapping classes, right? So frequency means how many times each and every class, the categories occurred in the each and every class occurred. How many times the particular category occurred, right? The number of items in each of several non-overlapping classes. So in the categorical means non-overlapping classes mean when we are taking the gender, male and female. These are the non-overlapping classes. Only two classes it has, male and female. They are non-overlapping. Non-overlapping male cannot be as a female or female cannot be male. Right? These two classes there is no any common element for these two classes. So that is called non-overlapping classes. When we are taking the qualifications, OL, the highest qualifications completed, O-level, A-level, graduate, right, postgraduate. So here, these are the 4 non-overlapping classes, right? So then each and every class, how many times occurred? That is denoted by the frequency. So simply, how we can define frequency? A frequency distribution is a tabular summary of data showing the frequency or number of items in each of several non-overlapping classes. What is the objective of these frequency distributions? To provide the insights about the data, right? That cannot be quickly obtained by looking only at the original data. When we are looking at the original data, if we are not able to get any information, that information we are able to get through the frequency distribution. So the frequency distributions provide the insights about the data. That means which non-overlapping class occurred mostly, which about non-overlapping class most of the observations surround it, which is the minimum occurrence, which non-overlapping class maximum occurred. These kind of informations we can get through the frequency distribution. Now we are taking a very simple example. Here we have a hotel. Here guests are staying and they were asked to rate the quality of their accommodations. So these quality of accommodations are measured with the excellent, above average, average, below average, or poor. These 5 measurements are used to measure the rating of the quality. Right? The ratings are provided by a sample of 20 guests. 20 guests were selected, and from those 20 guests, they were asked to rate the quality of their accommodation. Right. Now, in this example, what is the variable? Put the answer in the text box, the chat box. What is the variable? Quickly write the answer. What is the variable? The last class also clearly we learned. Yes, quality, not status of quality of accommodation, so quality of accommodation, right? Whether MS 68, what is continuous? Now I am asking the variable. You have to define the variable in terms of the given problem, right? For the given problem, you have to define what is the variable we consider. So based on this given scenario, the variable is quality of the accommodation provided by Maratha, right? So then, what is the measurement level of this quality? What is the level of measurement of this quality? What is the level of measurement for this quality? Now, rather than considering interval, just when we are looking at rate, ordinal, right? The level of measurement is ordinal. Why it's ordinal? Here we can compare it, right? Whether it's a better quality or now when we are looking at these two qualities, excellent and above average, we can say that the people put excellent. This is more quality than above average. Excellent is more quality than above average. Right. Whether is it continuous variable or discrete variable? Is it continuous variable or discrete variable? Is it continuous or discrete? Very good. It is a discrete. You have to look at the spelling clearly, right? Don't write the word terms. Actually, the technical terms, you have to write in the correct manner, right? So it is a discrete variable, right? Now it's correct, discrete. Then whether it's a qualitative variable or quantitative variable.
Qualitative.
It is a qualitative, very good. It is a qualitative variable, right? Now we identified the given scenario. What are the terms we learned in the previous session? All the terms here also you are identified there, right? Sorry, 1 minute. MS 68. Unmute your mic. MS 68. MS 68.
Yes, ma'am.
Why did you put it as a quantitative? MS68. The justification for its quantitative.
Sorry, miss, it's my mistake.
Even I told that it is a qualitative, then you are writing your answer as a quantitative. Huh? Right. And then these measurements were given, collected from the 20 guests. They rated in such manner. So these are the raw data. All these are the raw data, right? So now we look at the ratings are given here, and it is a frequency distribution. Now we are looking at how we are going to form the frequency distribution, right? So usually it is a small number of data. So when we are preparing manually, the first thing we have to form 3 columns. One is your variable column, right? Variable with those measurements. And here tally mark, and then we have to put the frequency column. So the variable is your quality, rating of quality of the hotel, Narada Inn. And these ratings are, the measurements of this variable are poor, below average, average, above average, excellent, right? So now we are going to look at how we are going to mark this one.
Recording stopped. Recording in progress.
Is it visible?
Yes, ma'am.
Yes.
Yeah, right. So now here we are looking at row by row. We are taking the tally marks by reading each and every observation. So the below average, here one tally mark we put, then average here we put another tally mark. Similarly, row by row, we are moving, right? Once you got 4 tally mark for the particular observation or measurement, then for the 5th tally mark, you have to put like this cross, right? Then again, for the 6th one, you have to start there. Similarly, so each and every 5, then we will start new one. So once you have 4th, then 5th one will be cross it, right? So similarly, complete the table for the tally marks and the frequency and tell what are the frequencies for that one. 2 minutes time is given, then complete it, the frequency distribution. So what is the frequency for poor?
2.
2. And frequency for below average?
3.
3. And frequency for average?
5.
5. And frequency for above average?
9.
9. And frequency for excellent?
1.
So total?
20.
Right. Right. So this is the frequency distribution. You have to complete the tally marks also. So first you have to complete the tally marks. Then find counting the tally marks, you can complete the frequency distribution. Right. From this frequency distribution, what is your observation? From the frequency distribution, what is the information? You can get it. Which rating occurred most? The most occurred rating, what is? The most happening rating.
Above average.
Above average. And also when we are looking at all over the frequency distribution, what is your conclusion? Whether their ratings are, the hotel quality is good or bad? When we are looking at the overall frequency distribution, whether the quality of accommodation is good or bad? What is your decision? How you can make decision when they are providing this type of information, and from this whether you will decide to go for that accommodation or not? So quality is good, right? Yes, the quality is good because almost 50% of the, right? Almost 50% of the guests rated the quality is at above average, right? 9 plus 1, 10. So 50% of the guests rated the quality of accommodation provided by Marathon is at above average. And also 75% of the respondents rated, right, the accommodation provided by Maratha Inn is at above average and above average. Right? Only 25% of the respondents rated the accommodation, quality of the accommodation is below average. So we can say that the residence provided by the quality of the accommodation provided by the Maratha Inn is at above average level. So it's very good for taking the accommodation from there. Right? So this kind of decision we can make quickly based on the frequency distribution. Right. Now we are coming for another type of frequency distribution, relative frequency and the percent frequency distributions. The relative frequency, but first we are looking at what is relative frequency. The relative frequency of a class is the fraction or proportion of the total number of data items belonging to the class. When we are taking a class, there is a frequency for that class. The frequency of the class is divided by the total number of frequencies. Then that number is called as a relative frequency. And then relative frequency distribution means it is a tabular summary of a set of data showing the relative frequency for each class. The frequency distribution, it shows the frequencies for each and every class. The relative frequency distribution shows the relative frequencies for each and every non-overlapping class. Then the percent frequency of a class is the relative frequency multiplied by 100, right? If a frequency is given in the percentage, right? That means when the relative frequency is multiplied by 100, then that frequency is called percent frequency. Similarly, the percent frequency distribution is the table which provides the data showing the percentage of the frequency for each and every class, right? Then now complete this table quickly. Relative frequency and percent frequency. And each and everyone, you have keep the calculator with you when you are coming to the class, right? Now, what is the relative frequency for first class poor? Tell the answer. What is the relative frequency for this one? Relative frequency for poor.
1.
Is it 1?
0.1.
0.1. Right, 0.1. What is the percent frequency? Percent frequency?
10.
10. We have to multiply by 100, right? The relative frequency should be multiplied by 100, then you can get the percentage of frequency. So that is 10. Then below average, what is the relative frequency for the class below average?
0.15.
0.15. And for the relative frequency?
15.
15, right? And for the relative frequency for the class average?
0.25.
0.25. And for the percent frequency?
25.
25.
COM 125. Unmute your mic.
Sorry, ma'am.
Why? Now why you are saying sorry? COM 125. Why this sorry? Huh? You raised your hands, right? Then for the relative frequency for above average?
0.45.
Right, 0.45. And the percent frequency? 45.
40.
It is 25. Right. Then for excellent, relative frequency?
0.05.
Right.
0.05.
0.05. And then the percent of frequency?
5.
5. Right. So when you are adding relative frequency, what is the total you will get?
1.
1. And for the adding percent frequency, what is the total you will get?
100.
Right? Right. So now when we are adding the frequency, we get the total number of observations. When we are adding the relative frequency, we will get 1. When we are adding the percentage of frequency, we will get 100. Right? So this is the relative frequency is proportion of the frequency divided by the, or proportion of frequency with the total frequency, right? Proportion of total frequency for a particular class. This is a percentage of the total observation, right? Percentage of the total observation for a particular classes, right? So in this case, there are 5 non-overlapping classes. What are the 5 non-overlapping classes for this example? What are the 5 non-overlapping classes for this example? Answer it. Unmute your mic and answer it. What are the 5 non-overlapping classes? Anyone? Now I use this word when I am describing the relative frequency or percent frequency. I use that term. So what are the 5 non-overlapping classes? These are the non-overlapping classes: poor, below average, average, above average, excellent. These are the 5 what are the measurements we are taking? All those measurements are the usually non-overlapping classes, right? So in these non-overlapping classes, we have show the frequencies and relative frequency represented. One is the frequency distribution. So frequency distribution means the frequencies for the non-overlapping classes. Relative frequency distributions mean it shows the relative frequencies for each and every non-overlapping class. Percent frequency means it shows the percentage for the each and every non-overlapping classes. Students, is my voice is clear?
Yes, ma'am.
Okay, because my internet connection shows it's not stable. That's why I asked, right? Okay, right? So now we are moving to the next slide. Right. Now we are looking at, for the qualitative data, how we can represent this frequency distribution via graphs, right? How we can use graphs to represent this frequency distribution. So actually, in most of the publications, they say that the importance of the graphs, rather than looking at the tables, the graphs are also very useful to get the quick information, or the readers are able to quickly view the important facts of the statistical data. When we are having a small number of observations, either the table or graph is both are okay. But when we are having a massive number of observations, then the quick view, the graph provides the quick view rather than the tables. So for the, when we are handling the massive number of data, it is better to represent, or it is better to give the graphs also in with the tables, right? Then easily we can grasp the ideas, right? So usually the bar chart and pie chart are the best choices for the qualitative data to represent the frequency distribution. Right. So first we look at bar graph or bar chart. Right. So in the bar chart, we can represent the bar chart frequency distribution by bar chart, or relative frequency distribution by bar chart, or percent frequency distribution by bar charts, right? So 3 types of frequency distributions we can represent by a bar chart. So in the bar chart, each and every category we can represent by the bars. So in that bars, length of the bar represent the frequencies. Even if we are using the relative frequency, then the length of bar represent the relative frequency or percentage frequency. Right? And the horizontal axis, we are usually specifying the labels that are used for the each of the classes. So in the horizontal axis, we are marking the labels for the variable or categories of the variable. And in the vertical axis, we are using the frequencies or relative frequencies or percentage frequencies. Right? So the height, actually, that should be appropriate scale. We have to represent the height with the appropriate scales, because based on the height or the length, then we can get the idea about what is the frequency or what is the relative frequency or what is the percentage frequency. And also in the bar chart, the bars between 2 bars, there should be a gap between, indicates that these categories are non-overlapping. They are not continuous, right? They are non-overlapping. To emphasize the classes are non-overlapping, we are giving the spaces between the bars, right? And also the bar chart may be either horizontal or vertical. We can represent the bars with the vertical, or we can represent the bars with the horizontal, right? Right. Now here we are taking the vertical bar chart for the same example. Earlier we considered the rating of the accommodations, right? The quality of the accommodations. So we have this frequency distribution. So now here we are taking the horizontal axis rating, right? Then there are 5 classes are there, non-overlapping classes: poor, below average, average, above average, excellent. Then here we are taking the frequencies in the vertical axis. So looking at the scales to denote the vertical axis, always it is better to start with 0, right? The vertical axis, we can always start with a 0. So it is 0. Then only there are maximum 9. So we are taking the scales from 1 to 9, right? So you have to clearly take the scales. That is also very important. But always you start with 0, right? That is one of the rules for plotting the graph, right? Always the vertical axis should be start with 0, right? Then here poor, this is a bar, right? The length denote the frequency, that is 2. Then for below average, the frequency 3. And for above average, it's 5. And sorry, average 5, above average 9. Then again for excellent 1. So what is the information we have from the frequency table? The same information we can get from the vertical, this bar chart also. And also you have to keep in your mind the width of the bar also you have to take for each and every bar. The width also you have to take it as the same. Then only your bar chart will give the nice look, right? The bar chart will give nice look. Even in the width of the bar also equal for each and every class, right? So then it is a column bar chart, right? This is called as a column bar chart. So when we are looking at having the column bar chart, we have to take the scales in the other way around, right? So in the vertical axis, we are taking the categories, and in the horizontal axis, we are taking the scales. So here, this is what type of bar chart. Now you say that what type of bar chart we have? Is it frequency bar chart or relative frequency bar chart or percentage bar chart?
Percentage bar chart.
It's a percentage bar chart, right? It is a percentage bar chart. So here also we are starting with a 0%, right? And here what is the variable? Variable in this scenario?
Internet. In-person
variable. What is
ATM.
the variable?
Banking preference.
Yes, it is a banking preferences, right? Banking method preferences. Preferences of the customers of banking methods, right? So which method most of the customers preferred? Which banking method most of the customers preferred?
In-person at branch.
Yes, in-person at branch, right? In-person at branch is mostly preferred. The less preferred banking method?
Automated or live telephone.
Oh, yes, automated or live telephone. So what are the what are the non-overlapping classes are here?
ATM.
Internet.
Right, ATM, automated or live telephone, drive-through service at branch, in-person at branch, and internet. Whether it is, what is the measurement level for this variable?
Ratio.
You have to look at carefully what is the measurement level of this variable. Your variable is the banking preferences, right? Then what is the measurement level?
Ordinal.
Why you are saying it's ordinal?
Irregular.
Huh? What are the, right, now you look at, now you know that the variable is banking preferences, right? Preferences of the banking methods. Then what are the measurements we used to measure the preferences? What are the measurements we used to identify the banking preferences? Or what are the measurements of the variable? What are the measurements of the variable? Still, you are not clear with that. Quickly, you can say that. What are the measurements of the variable?
Percentage.
Huh? Percentage is that is not the measurements of the variable. Even in the previous example, you say perfectly what are the measurements of the variable. Here the percent, what is here the percentage says? The percentage says how many, but what is the percentage of the customers preferred ATM? What is the percentage of customers preferred automated or live telephone? What is the percentage of customers preferred drive-through service at branch? What is the percentage of the customers preferred in-person at branch? Similarly, that is percentage measures how many, or what is the percentage of the customers preferring each and every banking preference method. So now the question is, what are the measurements of the variable, the banking preference? So many examples, we learned that one. To identify the variable, to identify the measurements, to identify the level of measurement, to identify whether it's a discrete variable or continuous variable, to identify whether it is a qualitative variable or quantitative variable. Again, here you stuck. Right, now I am taking a simple example. Gender, right? So what is the measurement for gender?
Nominal.
Male or female?
Male or female. Measurements for gender are male or female. Right. Similarly, what are the measurements for the banking preference?
16%.
Now say that. Still I explained that. What is 16? 16 is a 16% of the customers preferred the ATM method. Banking customers are the respondents. They are the elements or entities of the study. What are the measurements for the banking preferences?
ATM. Automated.
Internet.
Right.
Percentage.
How many measurements here we have?
5.
5.
5 measurements. These are the measurements. ATM, automated or live telephone, drive-through service at branch, in-person at branch, internet. Okay. Now you tell that what is the level of measurement?
Nominal.
Nominal. Yes, because here we cannot have meaningful difference. We cannot have meaningful comparison. We cannot have meaningful ratio. So the level of measurement is nominal. So if we want to identify the level of measurement, the first, what is the thing you have to look at? Measurements of the variable, right? Measurements of the first, you have to identify the variable. Then you have to identify the measurements. If these two things you have clearly, then the other matters, you can clearly answer it, right? So what are the first two things we have to look at? To identify what type of variable, what are the measurements, all the things to identify. What are the main two things you have to look at first? First, you have to look at the variable of the study, right? First, you have to look at the variable of the study. Then you have to look at what are the measurements we have for the variable, right? So here the variable is banking preference. Then measurements are these 5. ATM, we are measuring the banking preferences, method of banking preference. ATM, automated or live telephone, banking methods preferences, drive-through service at in-person at branch, and the internet. So based on these measurements, we can say that it is a nominal level of measurement. Now, have you have understanding on it? Yes,
Yes.
or no? Yes.
Yes.
Right? Right. If you have any doubt, then you can ask me, right? Right. Okay. Now whether the variable is discrete variable or continuous variable?
Discrete variable.
It's a discrete variable. Yeah, why it is a discrete variable?
Because it's non-numerical.
Non-numerical. Also, it's measured by categories, right? Even numerical also may be discrete, right? So that answer is not appropriate. Numerical also discrete. In some cases, numerical also discrete. So here, these measurements are the categories. So it is a discrete variable, right? Then whether it is a qualitative variable or quantitative variable.
Qualitative.
Why it is qualitative? Why it is qualitative?
Because it is non-numerical.
Yes, because it is non-numerical, right? So the first thing, if the students, you are not clearly with this concept, first you take the first chapter and learn it, right? What is variable? What is measurement? What are the levels of measurements? How we can identify those levels of measurements? Then what are the data, right? Then whether it's the variable or data, whether it's a qualitative or quantitative, whether it is a discrete or continuous, these kind of first to go through the chapter 1 clearly, right? Based on the given definitions, right? Then only you can easily identify, right? Right. So now here, these percentages are what type of distribution here we have? Percentage distribution, right? We have a percentage frequency distribution, because 16% of the customers, this 16% means 16% of the customers preferred the ATM as a banking method, right? 2% of the customers preferred automated or live telephone banking method. 17% of the customers preferred drive-through service at branch. 41% of the customers preferred in-person at branch, and 24% of the customers preferred internet. So these are the how many customers or what percentage of customers preferring each and every method. These are not measurements. The measurements of the variables are these. So based on these measurements, there are 5 non-overlapping classes. These are the 5 non-overlapping classes. So in the horizontal graph, we are taking the overlapping classes in the vertical axis and the percentage in the horizontal axis. So if this type of graph is called the horizontal bar chart, right? Then is there any doubt on this graph? So based on this one, what is your decision? Based on this graph and the percentage distribution, what is your decision regarding the banking preference methods, the preference of banking methods? How you can make the decision? Suppose the banking manager asks you, you are joining as a trainee of statistician. Then the bank manager gave this chart, and he asked, what is the decision regarding, based on this chart, what is your decision? You put your decision in the chat box. How you can make decision? Write the decision in the chat box regarding the preference of banking methods. What is the information you are going to give to the bank manager. These are the main things we will expect from you, right? Not only the calculations or graphs, right? That also you have to know that in addition to that, because why we are taking this graph, the tables or graphs, we have to convert the raw data to the useful information. And from that information, we have to make the decision. So the decision is very important. So from that one, that also, okay, should improve automated or live telephone banking. That perspective, the manager will take, right? Now you have to give the information based on these statistics. This decision is taken by the manager, right? This decision taken by manager. In the statistical perspective, what is your decision? That decision you have to give, not this one. Based on these statistics, what is your decisions regarding the preference? Banking methods, preference of banking methods. Yes, most of the customers prefer to do banking in person at branch. That answer is right. Most of the persons, people banking preference is being in person at branch, so it should be developed, and less preferred preference is automated or live telephone, so it should be developed more. That also okay, but the mostly thing we expected, most of the people or most of the customers, right? People banking preferences being person at branch, and the less preferred preferences automated or live telephone. Now this answer is perfect, right? The developing or improving, that is actually, that part will take by the managers, not us. The statistician, based on these stats, what are the information you want to give? So you can put in the bracket also, most of the customers, around 41% of the customers preferred in-person at branch method, and the less number of customers, only 2% preferred the method automated or live telephone banking. Then the bank will decide, the bank manager or executive officers or chairman, or they will make the decision whether we are going to drop down the automated or live telephone, and more improvement we are going to give for the in-person at branch or internet, right? So if they also, they will analyze why this internet banking is not preferred comparing to in-person at branch. Then they identify what are the defects are there. Then they will try to improve that methods, right? So these kind of decision will make by the managers of the bank, right? But as a statistician, from these observations, we have to give which is the most preferred method and which is the less preferred method, right? Those are the things we can give. And the second most preferred method, that also we can give. The second most preferred method is internet banking method, right? Then the bank will think about, if they want to promote the internet banking, then they will learn, research it. Why the internet banking method are not preferred by the customers comparing to the in-person at branch. Then identify whether there is any service quality problems, or is there any other problems with the internet banking. Then they will identify those defects or limitations on the internet banking, And based on that one, they will improve it. That is the manager's part decision, right? Okay. Now, again, we are coming with another chart, pie chart, right? This is also commonly used graphical device for presenting the relative frequency distribution, right? The bar chart, for 3 cases, we can present almost, right? Frequency distribution, relative frequency distribution, percent frequency distributions. But Y chart, mostly we are present for the relative frequency distributions for the qualitative data, right? So the pie chart is a circle that is divided into sectors that represent categories, right? The area of each sector is proportional to the frequency of each category, right? Proportional to the total frequency of each category. Right? So first we have to draw the circle. Then we have to use the relative frequencies to subdivide the circle into sectors that correspond to the relative frequency. So in the circle, the degree is 360. If the relative frequency for a particular class is 0.25, then the area of the pie chart is will be found by 360 into 0.25, that is 90 degrees of the circle. Then we can draw the pie chart, right? So here we will not expect pie chart by manually, right? But in the 3rd year, then we will use the softwares to draw the pie charts. We use the software to draw the pie charts, right? So manually, actually, we will not ask pie charts, right? But you have to know that how we can construct pie chart. That point you have to know that. Right. Here also we are taking the pie chart. This is the alternate form of percentage frequency distribution and the percentage bar chart. Right. So here easily we can compare. Right. This is the higher area comparing to this one. All right. So the same decision here also we can make that, right? So the pie chart is a circle broken up into slices that represent categories. The size of each slice of pie varies according to the percentage. So here we can compare all these categories using the area of these sectors, right? So here the different colors we are using to distinguish the sectors sectors taken in this banking preference methods, right? Then how we will look at how we can plot the pie chart. Here we are taking the deaths, accidental deaths in a country. Right. Now you look at this frequency distribution. Right? What is the variable here we considered? Look at this frequency distribution. And what is the variable here we considered? You can unmute your mic or you can put in the chat box. What is the variable we considered? Little more description is needed. No. Not perfect description. half away you have, yes, accidental deaths. Right? Types of accidental deaths occurred in a country in 2017. Types of accidental deaths in a country. Right. What are the measurements taken to this variable? What are the measurements we take? Unmute your mic and tell it. What are the measurements we take for the variable described?
Motor vehicle, falls, poison.
Very good. Motor vehicle, falls, poison, drowning, fire, ingestion of food object, firearms. These are the measurements we take. Whether it's a nominal, what type of level of measurement? What is the level of measurement for this variable? Nominal level of measurement, right? Whether it is a discrete variable or continuous variable.
Discrete variable.
Why it is a discrete variable?
Categories.
These are the categories, right? We take the categories are the measurements, so it is a discrete variable. Whether it is a qualitative or quantitative. Is it qualitative or quantitative?
Qualitative.
Sorry. Is it qualitative or quantitative?
Qualitative.
Qualitative, right? Because we measured with a category, so it is a qualitative, non-numerical value, so it is a qualitative. What is the meaning of 12,200? What is the meaning of? Clearly, you have to tell what is the meaning of 12,200. Not, you can't say that just false. What is the meaning of 12,200? What this number explains?
False.
12,200 deaths occurred due to false. Right? 12,200 deaths occurred by false or due to false. What is the decision from this you can make? What is your decision from this frequency distribution?
More accidental deaths in 2070 is by motor vehicle.
Yeah, most number of deaths occurred in 2017 by motor vehicle accidents, right? By motor vehicle accidents. What is the less number of deaths occurred? Which type of accidental death are less? Firearms, right? Only 1,400 deaths, which is the least number of deaths, occurred in 2017 by the firearms. Right? Right, okay. Then, what are the non-overlapping classes? How many non-overlapping classes are here?
7.
These 7 are the non-overlapping classes. Motor vehicle, false, poison, drowning, fire, ingestion, and firearms. These are the 7 non-overlapping classes. So it is a frequency distribution. It indicates the types of accidental deaths and the frequencies. So it is a frequency distribution. So to plot the pie chart, next what we have to calculate. To plot the pie chart, the next what is the thing we have to calculate?
Relative frequency.
Yes, relative frequency. How we can calculate the relative frequency? How we can calculate the relative frequency? For example, for the motor vehicle, how you can calculate the relative frequency for motor vehicle?
motor vehicle frequency divided total frequency. Total
Yes,
frequencies.
yes. You have to get you have to get the total number of frequencies by adding all those frequencies, and then you have to divide the motor vehicle frequency 43,500 divided by the total number of frequencies. Similarly, each and every relative frequency you can calculate. What is the next thing you have to calculate?
Angel.
Sorry? What is the next thing after calculating the relative frequency? What is the next thing you have to calculate?
Percent frequency.
Degrees, right? The pie chart degrees, right? Area of the pie chart. How you can calculate the area of the pie chart?
By multiplying the relative frequency into 360.
Yes, the relative frequency should be multiplied by the 360, right? Then you can plot the pie chart, right? Right, so we calculate the relative frequency and then we calculate the angle, right? Not the angel, angle, right? Angle or area, right? Right. Then pie chart or bar chart. When you have two options, right? To represent the category qualitative variable or categorical variable. For the graphical form, you have two options, pie chart and the bar chart. So now you have to decide whether to use a pie chart or bar chart. How we can decide it? It's depending on the properties of the data. You have to look at the data, right? Before drawing the pie chart or bar chart, first we have to prepare the frequency distribution. Whatever you are going to take the pie chart or you are going to take bar chart, anyway, before taking these charts, you have to first prepare the frequency distribution based on your raw data. When pie charts are effective, the pie charts are mostly effective for comparing the given categories, right? That is a slice of the pie. We are looking at the percentage, almost the percentage, the total, whole pie. We are comparing a given category over the total. We want to compare the given category over the total. And also, the categories are close to 20 or 50%. If it's a very small, 0.002%, right? Or it is very 0.05%, then actually it is very difficult to compare, right? The area of the sector will be very, very, very minor when the percentages is very small. So the percentages should be close to 25 or 50%. Then it is most preferred method, pie chart. Easily you can look at the compare the given category with the total, right? But the bar charts offer a better option to show subtle differences between the categories. Major differences, very smallest to very largest, then the bar chart is more preferred, right? And also the number of categories. When we are taking the pie chart, 6 or 7 categories, the non-overlapping classes, 6 or 7 non-overlapping classes, then the pie chart is better. But the number of non-overlapping classes are high, 10 classes or 12 classes, then it is better to go for the bar chart, right? So you have to look at the number of categories, the percentages of each and every categories, and the objective, whether we want to compare over the total. Based on these facts, we have to choose whether it's a pie chart or bar chart, right? Now we are coming with the quantitative data, summarizing the quantitative data, right? So for the quantitative data also, we can summarize using the frequency distributions, relative frequency distribution or percent frequency distribution as it is in the qualitative data. But when we are looking at the charts, we have to take the histogram or cumulative distributions, right? cumulative distribution graphs or histograms we can choose to represent the quantitative data. Right. So for the numerical data, that means for the quantitative data, we can use ordered array, frequency distributions, and the cumulative distribution. These three kinds of distributions we can use for organizing or presenting the numerical data with charts, tables. Right? Ordered array, frequency tables, cumulative distribution frequency tables we can use. What is ordered array? This is not actually just we are arranging the data in the order of magnitude, from the smallest to largest or from the largest to smallest. That is called as an ordered array. Ordered array is a sequence of data in ranking order from the smallest to the largest value. So when we are ordering this data, we can easily identify the range. Range means the minimum value to maximum value. What is the minimum value and what is the maximum value? From which value to from which value we can find out, right? And also it is very useful to identify the outliers, right? That is unusual observations. That is the main thing of the numerical data. In some cases, we have some unusual observations. Actually, what is the meaning of unusual observations? It is a very, very smallest value comparing to other values, or it is very, very big value comparing to other data values. If some observations are very, very small comparing to other observations, or it's very large comparing to other observations. So that is called as outliers. Suppose, for example, when we are looking at the salaries of the employees, right? So when we are looking at the salaries of the employees, say that most of the employees are earning the salary from 30,000 to 50,000. Most of the employees are earning the salary from 30,000 to 50,000. But only very few employees, their salaries are 300,000, around 300,000. So here, this 300,000 values are unusual values for comparing to these other salaries, right? 2 or 3 values are around 300,000 to 400,000. So these 300 to 400,000 salaries are unusual observations comparing to the other salary values in the given data. So when we are arranging the data in the order from the smallest to values, these two things usually we can identify. Range and the outliers only. Also, the most occurred values also you can identify. But this ordered array is very useful when you have very small number of observations. We have only very small number of observations. Otherwise, it is very difficult. Even 100 observations or 50 observations also very difficult to make the order, right? Only 10 or 15 observations, then easily we can use the ordered array to summarize the data, right? So for example, here we are looking at the, right, now you look at this data and identify the variable of this data. What is the variable of this data? What is the variable for this given distribution? Ordered array. Now it is in the ordered array, right? This table represents ordered array. What is the variable for this study or for this data we considered?
Age of surveyed university student.
Yes, age of the surveyed or age of the university students or surveyed university students, right? What is the measurement here we take? What is the measurement for this variable?
Day students, night students.
Students, what is the measurement for this variable?
Day students, night students.
No. Now your variable is age. So how we can measure age? What is the measurement of this variable? In years, we are taking the measurements in years, right? Age are measured by the year, 16 years, 17 years, 18 years. So in this case, the measurements of this age is years, right? Are you okay?
Okay, miss.
Yes. Measurements of this age is years. In some cases, we are measuring age with months. In some cases, we are measuring the age with the days. So, but in this case, we are looking at the age of the students. We are measuring with the years, right? So, number of years. Age is measured by number of years, right? Then from this, measurement is years. Then what is the level of measurement?
Ratio.
Yes, ratio. Because why you are saying that it is ratio?
0 is not meaningful.
0 is not meaningful here. Why? Age is ratio, level of measurement.
Zero is meaningful.
Yes, 0 is meaningful. And the three reasons you have to say that. The difference is meaningful, comparison is meaningful, and the ratio is meaningful. There is a meaningful 0. If the meaningful 0, then ratio is meaningful, right? So these three properties are obeyed. So the level of measurement is ratio, right? Then whether it is a discrete variable or continuous variable.
Continuous.
Why it is continuous? Why it is continuous? Why it is continuous?
Because it can take fractional units also.
Yes, because now we are saying that 16 years and 7 months, right? So it takes a fractional points. It can take the fractional points. 17 years and 2 months. So it can take the fractional points. So it is a continuous variable. Is it qualitative or quantitative variable?
Quantitative variable.
Quantitative.
Why it is quantitative?
Because it's numerical.
It takes a numerical values, right? It takes a numerical values. We are measuring with the number of years. So it is a quantitative variable, right? Okay. Right. Now, what is from this ordered array, what are the information you are taking? From this ordered array, what are the information you are taking? From this ordered array, what is the information you can get it? first you look at the day student, and here you look at, there are two things we gave. From the time being, you omit this one. You don't know easily identify the outliers now. For the time being, you omit this point, and looking at this point, and what is the decision here you are taking? Otherwise, you can put the answer in the chat box also. What is the decision based on this point? What is the decision you are taking? Only these are the two things we can derive from the ordered array. But for the time being, you will leave the identifying the outliers based on this fact. What is the information here you are taking?
Day student maximum age 42.
Not only maximum, then minimum also you have to say that. Yes. For the day students, the ages range from 16 to 42. Right? So if we are saying that, then minimum value is 16, the maximum value is 42. The day students' ages range from 16 to 42. And the nighttime students, part-time students' ages range from 18 to 45. Right? Now, for the time being, you leave the outliers. Now, it is very difficult to identify whether we have outliers because 16 to 42 almost close to each other. So now it is very difficult to identify whether there are outliers. So leave that one. Now only we can identify the range clearly, right? So the age of the day students range from 16 to 42 years. And the nighttime students' age is ranging from 18 years to 45 years. This is the thing we can get from the ordered array, right? Right. Now we are looking at how we can construct frequency distribution for quantitative data, right? How we can construct frequency distribution for quantitative data. A frequency distribution for quantitative data lists all the classes and the number of values that belong to each class, right? A frequency distribution for quantitative data lists all the classes. Here also the non-overlapping classes and the number of values that belong to each class. As it is in the qualitative data, here also we have to have two columns. One is the classes and the other one is the number of frequencies, right? So data presented in this form is called the group data. Right? Almost for the numerical data, we can form two types of frequency distributions. One is the ungrouped frequency distribution and the grouped frequency distributions. We are giving the classes in the interval form, that is called as a grouped frequency distributions. If we are giving just only the numbers without classes, then that is called an ungrouped frequency distribution. Right? An interval, that is a class, that includes all the values that fall within two numbers. The lower and the upper limit is called a class. The classes are non-overlapping. Example, here you look at class 1, 4. So what is the meaning of 4? Here, the numbers in between 1 to 4, the numbers including 1 to 4, 1 and 4, and in between 1, 4 times occurred. Right? Here, the 5 means the number in between 5 and 8, in between 5 and 8, and including 5 and 8, 5 times occurred. So, 3 times the numbers 9 to 12, 3 times occurred. The numbers 13 to 16 4 times occurred. The numbers 17 to 20 2 times occurred. So this called as classes. These are the non-overlapping classes. How we are saying that non-overlapping classes these are? How we are saying that these classes are non-overlapping classes?
Because there is no common value between those classes.
Yes, because only this interval includes only the numbers from 1 to 4, right? This class includes only the numbers from 5 to 8. So the one number cannot fall this class or this class or this class or this class, right? Only this class includes the numbers 1 to 4 and this class includes the number 5, 8. So these two classes are non-overlapping classes, right? So these are the frequencies. And these are the starting number of the class are called lower limits. The starting number of the classes are called lower limits. The end number of the classes are called upper class limits, lower class limits and the upper class limits. So if we are taking 1 to 4, 1 is the lower limit of the class and 4 is the upper limit of the class. Then class width. The class width is the distance between the lower or upper limits of the consecutive classes, right? So now you tell the class width. What is the class width for this first class, this frequency distribution? What is the class width?
4.
Huh? What is the class width? Look at this definition and find out what is the class width.
Two.
Clearly read it. Read the first sentence carefully and then say that what is the class width.
4.
Yes. How did you say 4?
5 minus 1.
Yes. Right. Now here you read it. The class width is the distance between the lower or upper limits of the consecutive classes. So these two are the consecutive classes. So we have to take the distance between the lower limits of the consecutive classes or upper limits of the consecutive classes. So if we are taking two classes, this is the 5 lower limit, this is the 1 lower limit of these two classes. 5 minus 1, 4, or 8 minus 4, 4. In another way also we can find out by looking at the difference between the class boundaries of a particular class. Little later we will look at, right? Now don't confuse that with that one. Now based on this definition, the class width you can identify 5 minus 1 or 8 minus 4 or 13 minus 9, 16 minus 12, all are the 4 class width. So here this frequency distribution has equal class width, right? And the range is the difference between the maximum and the minimum data entries. The range of this frequency distribution is the maximum and minimum data entry. So what is the range for this distribution? What is the range for this distribution?
3.
For the frequency range is 1 to 4, right? The range is 1 to 4. Now I am asked, that is for a particular class. Now I am asking the range for the frequency distribution, not for a particular class. Range for this frequency distribution. 19, yes. 20 minus 1, or it is range from 1 to 20, right? The range is a difference between the maximum and minimum data entries. So the range for the distribution, frequency distribution is 90, or you can say that it's range from 1 to 20. Then why we are using the frequency distributions, right? In the context of quantitative data, it condenses the raw data into more useful form, right? It condenses the raw data into more useful form. It allows for a quick visual interpretation of the data. It enables the determination of the major characteristics of the data set, including where the data are concentrated or clustered, right? Where the data are concentrated or clustered. Hello? நான் இதை டிக்கெட் கேன்சல் பண்ணினானே. கேன்சல் பண்ணிட்டு எனக்கு மார்ச் 1க்கு போடணுமா? நான் இது கேன்சல் பண்ணிட்டேன். சரிவா? ஓகே ஓகே. Right. So these are the advantages why we are using the frequency distribution, right? So it summarizes the raw data into more useful form. It allows for quick visual interpretation of the data. In addition to that one, you are able to determine the major characteristics of the data set, including where the data are concentrated or clustered. Right. Now, look at this point. And based on this point, can you say that where the data is more concentrated for this case? In this case, where the more data are concentrated?
Recording stopped.
Hello. Hello.
Hello, students. I'm going to stop this class because of power cut. So in the next class, shall we meet?
Okay, miss.
Right. So next next Friday also, what time we have? 8:30 or Friday time? No. Friday 1033, right? So if it's a power cut, otherwise we will start with a 9:30. And if it's power cut, then I will inform to you the time. Huh?
Okay, ma'am.
And where is the class web? Danushan? I think Danushan is not there. Otherwise, you have to give a number. Can you text a number, the student who is regular to the class? Because now I call the Danushan number, Danushan is not answering, right? So that's why again I connect and commit there. So can you text any number who is regularly attend the class? Put in the text box, please. Even commerce or management, right? Who is regularly attending the class? I want the number with your name. Voluntary. Now my computer is going to off. So can you text quickly? Students? To pass the information, I am asking the phone number.